Okay, so a few examples for finding the mean for a test when you have a sample test. We test the claim that the mean GPA of night students is larger than 2.7 at a 0.1 significance level. Then when we're writing our hypothesis, first one's the null, the second one's the alternative. Null is always equal to your population mean. So this would be equal to 2.7. So the first one is always equal to, then the second one is what you're testing. In this case, it said larger, so we're testing that it's larger than 2.7. Because it's testing larger, as it said in earlier explanations, greater than or less than is one tail, and then greater than would be a right-tailed, less than would be left-tailed, and not equal to is two-tailed. So in this case, we're testing greater than. So it's a right-tail test. Based on a sample of 34 people, the sample mean was 2.72 and the standard deviation was 0.18. And so we want to find the p-value the significance level that was given. It's the 0.10. And then, well, we'll see why we reject once we find this p-value. To find the p-value using the calculator, clear this. We go into stats and we go over to test. Now, even though our sample size was 34, go back here for a minute. Our sample size is right here, 34, but the standard deviation is from the sample. So you would still use the t-test and not the z-test. The only time you use the z is if it's greater than 30 and the population standard deviation is given. So we use the t. Let's try it. So we want to go over to test. And then we want the t-test, so we need to do number 2. Or go down 1 and hit enter. We're not given data, so we use stats. And then we type in our values. Our mean was that's the population, 2.7. And then the sample was 2.72. And standard deviation, what's this? And our sample size was 34. We were testing greater than. So if it's less than or not equal to, you'd use these. Blue is just what color it's going to print. You can print different colors on them. And then we calculate. So our t-value, if you needed it, is 0.64788. Here's our p-value, and I believe we just needed the p-value, 0.26077. P-value, 0.26. We only had to go 3 decimal places. So it rounds to 0.261. This came from here. Now when you're finding whether to reject or not, you want to look at the p-value and see how it compares to this. Since the p-value is greater than the significance level, we do not reject the null hypothesis. If it was less than, we would reject it. Let's try another one. On this one, we're given the data. So instead of being the sample mean and standard deviation, you're given the data, so you need to enter that in. So if we go to our calculator, clear our screen, to enter data and go under stat. Now, if you already have stuff there, you want to clear the list first. But to just enter it, notice this one says edit, hit enter, and you type in your data. Now, I already typed it in. So this was all the data values. You just type the number, hit enter, type the number, hit enter. And you can use your keypad on your computer so it goes faster. Once we have that entered, second and quit, then you do the same thing. You go into stats, you go over to test, and it was also a t-test. But in this case, out of stats, we want to move over to data because we're using data. So then this changes a little. Notice it's saying what list the data is under. But we do have to fix our mean, which for this one, the population mean was 65. I guess we didn't read the whole problem. The statistics students believe that the mean score on a first statistics test is 65. The instructor thinks that the mean score is higher. Notice higher means we were testing greater than. There we go. That's why this is greater than. The instructor thinks it's higher. She samples 10 students, so it's a small sample, and obtains these scores. So those are the scores that I entered. And we need the mean, the sample error t-value, and the p-value. So we're testing greater than. If we go to our calculator, we know that's 65. We have our list. Leave the frequency 1. I always leave it 1. And then we're testing greater than. And hit calculate. It tells you the mean's greater than 65. Gives you your t-value, which you needed. It gives you the p-value, and it gives you the mean. Now, look at the standard deviation. 11.888. Now, what they asked for, so there's our mean, our t-value it gave us, and it gave us the p-value, but it did not give us the standard error. The standard error is the standard deviation divided by the square root of the sample size, which in this case was 10. 3.76. Oh, they went larger. 3.7593. 3.7595. Now see the decimal, depending on how you're solving it, you could have these little decimal errors. I would say that if you're rounding hundredth, thousandth, sometimes they're a little bit different, and so I will check for those. But I don't know, what did it say? It doesn't say what to round to. So I would accept, in any case, I would accept that if it was that many decimal places. But that shows you everything for this one. Now, since that p-value is less than your 5% confidence level or significance level, you reject it. So when it's less than, you reject it. When it's greater than, you fail to reject. Let's try one more. The average student loan debt is reported to be $25,235. The student believes that the debt is higher. She takes a random sample of 100 college students in her area and determines the mean student loan to be $27,524 with a standard deviation of 6,000. Is there sufficient evidence to support her claim? Well, the first thing is we need to decide if it's a T or a Z. N is greater than or equal to 30, but it's still a t-test. The reason it's still a t-test is because this standard deviation is from the sample and not the population. And so you're still using a t-test. The null hypothesis is always equal to the population mean. And then we were testing greater than, and that's why this is greater than. To find the t-value and the p-value, we go back to the calculator. There's our screen. Stats, over to test, down to the t-test. Now this time we have the statistics again. And our mean from our hypothesis was 25,235. The mean from the sample was 27,524 with a standard deviation of 6,000, and we had a sample of 100, and for some reason all the examples I picked were greater than. Let me calculate. Our t-value 3.815. The p-value. Now notice the p-value, they have e to the -4. That means you want to take this decimal place and move it over 1, 2, 3, 4 spaces. So when you do that, you have this. This is equal to the 1.0 times 10 to the -4. So you're just moving your decimal over, and that's how they got this small value. Since this is less than 0.05, we reject the null hypothesis. So that should help you with the first two sections of Chapter 9.